Good morning, everybody. This is Cassie Stumo. I am the marketing specialist here at EAC. Thanks for joining us today for our webinar. We'll start off today with an intro of EAC, and then PTC's technical specialist, Emily Pinto, will show us how to create rapid toolpath generation in Creo Mold Machining. Everyone gets a recording of the session pending any technical difficulties. There will be a short survey that appears once the webinar is over, so hang tight once we're done, and then drop your questions in the queue along the way. So first off, I'll tell you a little bit about who we are. At EAC, our mission is to transform the way companies design, manufacture, connect to, and service their products. We're more than just a value-added reseller for PTC. We've been partnered with them for over 20 years with experts in 22 areas of product development. We're located all over the US with our headquarters in Minneapolis, Minnesota. We offer our customers everything they need for product development, from CAD and simulation software for the full product design process, software for managing service documentation, and software for managing product data. We assist with design and engineering projects and offer webinars and PTC certified training courses for continuous learning. We also implement the industrial Internet of Things and augmented reality into business strategies to jumpstart initiatives around digital transformation and connecting all things in your company. We also offer our customers Formlabs desktop SLA printers at packages starting as low as $34.99. So really we just try to make sure that you remember who we are as a company. If you need to partner with somebody to get all of the technology that you need, we're here to make your team successful. So I'll go ahead and hand things over to Emily so she can get started.
Thank you. So my name's Emily Pinto. I work for PTC in the Virtual Center of Excellence. And my group, we specialize in giving high-level overviews of all of our different PTC products. So today, we're going to talk about Creo Mold Machining, or the MMX. This is the Creo Mold Machining Extension, which is all of the tools that you would need inside Creo Parametric for quickly and easily creating high precision mold machining toolpaths. So let's talk about some of the challenges that face people in this industry. So we see all the time discrete manufacturers are under increased pressure to deliver really high quality products, both on time and under budget. And customers expect to pay the lowest global price, in addition to that. So manufacturers are really trying to lower prices to compete for that new business and lower manufacturing cost in order to maintain and grow revenue and profits. Increased demand for quality and shorter manufacturing lead times are a big challenge as well. There's a big need to deliver high quality mold and dies on time. There's a struggle to compete and win new business, and really a need to support high speed, efficient machining in order to satisfy this. And a big problem is reliance on third-party solutions to support that high-speed machining strategy because there's a lot of lost time and effort translating and moving data between the two systems. There's a lack of integration when you use disconnected CAD and CAM software, so the NC toolpaths are not updated when design and tooling changes are implemented, which costs a lot of time. And this all causes, the inability to deliver parts and tooling on time and under budget when you run into these errors and wasteful practices. So there's a need to eliminate this data translation and enable concurrent design and manufacturing to speed that process up. And so our solution, PTC's solution to this, is the Creo Mold Machining Extension, which provides specialized 3-axis machining capabilities inside of your Creo environment for toolpath generation and simulation. So this solution provides those specialized NC machining capabilities that are optimized for mold, die, electrode, and prototype 3-axis machining. So machining tools with mold and die machining in mind. So a lot of really high precision, easy to use tools. So let's talk about some of the capabilities. This is an integrated mold machining tool that's powered by module work. So like I said, this is optimized for the mold die, electrode and prototype machining. There's easy creation of high-speed precision toolpaths because you can rapidly create these high-quality 3-axis roughing and finishing toolpaths using Creo's intelligence and the intelligence built into this tool. It also has support for high-speed precision 3-axis machining strategies with multi-core and multi-threaded calculations for that high-speed calculation. So really supports the high-speed strategy, no matter what strategy it is that you're using. And so this is an integrated CAD CAM system, which allows you to support concurrent design and manufacturing because there's a streamless workflow to move from design to manufacturing, and you can have that automatic change propagation and associative update of the NC toolpath. So if there's a change made on the CAD model, well, your NC toolpaths were created on that same model. So it's very easy to update that geometry, update the toolpaths accordingly. And Creo can do that for you automatically if that's what you need. So let's get a little bit deeper here, and then we can look at a demonstration of what this looks like inside of Creo. So the first thing we're going to talk about is the ease of use, and this is really important because a lot of these NC tools can be very complicated to use. So though we have all of the power of any other NC toolpath, it's a very powerful tool. It's going to be a really simple user interface and the familiar Creo command ribbon. So you're going to have context-sensitive menus, and you're going to have that ribbon bar command access. We also have automated toolpath creation. This is something that makes this very easy to use. You can use defaults and intelligence built into the tools to have Creo automatically create very quickly these high-speed precision 3-axis toolpaths. And they're going to be, if there's something that needs to be tweaked then from the automatically generated toolpath, of course you can see here this drop-down menu. You do have parameters you can change, of course, but all the intelligence that's built in and the defaults that you're able to set, you can get most of the way there with Creo doing the bulk of that work for you. And of course then productivity and usability tools. So you have user-defined macros and templates, setup sheets, and tools database with stored parameters. So if you're using common strategy, if you're using a particular tool very often, there's no need to redo that work every time. Save it as a template, keep it in your tools database with those stored parameters as defaults, and allow Creo to accommodate that to the new geometry that you have with each new part. So the embedded CAD and CAM is really important here because you're going to have that seamless integration between the two. And that's because the 3D CAD that you've used to model to create your design for your part is directly used for manufacturing. So there's no translation, no need to copy geometry, there's no CAD model cleanup. This saves a lot of time, a lot of error, a lot of rework. Toolpaths are also associative linked to the CAD model, which I mentioned earlier, and that means that toolpaths are automatically updated when designs are modified, if that's how you choose to do it. And the great thing about this is that, as I mentioned earlier, where using the templates, that it saves the strategy, but it can accommodate new geometry from part to part. It's that same technology that allows you to change the geometry of your CAD model, make a change, make a part thicker or thinner, or add a wall or a ledge. And your toolpath's going to automatically accommodate for that using the same strategy, but working around the new geometry. We have comprehensive 3-axis machining. So that means we have 3-axis trajectory toolpath, comprehensive hole making sequences. So you don't have to waste any time creating your own hole sequences if you don't want to. Those come standard. We also have high-speed machining that is powered by module work. So it's really high-tech, high precision for all adapted roughing, rest roughing, finishing, and rest finishing. So again, this intelligence, the precision, the calculations, they're all built and done for you ahead of time. That fast toolpath calculation, this is due in large part, I should say, to the multi-core and multi-threaded cores used for high-speed calculation. So this is a very optimized calculation process. And then once you have that toolpath and data structure, it's represented in a very lightweight way. So these toolpaths are not going to weigh your model down. It's a lightweight toolpath data structure. You also have a high data processing capacity and various levels of caching. So a lot of really great capabilities around that fast toolpath. The last capability we're going to talk about is this simulation, which is really crucial to having a well-working NC toolpath, and that's because we have collision checking and collision-free machining. So you can see your toolpaths inside Creo, check to see if it's going to collide with anything, if there's going to be a gouge, highlight that in red. There's that toolpath simulation right inside your Creo environment, as well as the stock removal simulation. So you can actually visualize the workpiece and see that material being removed by that tool as it passes along, as it goes through each of those passes. So now we're going to take a look at what this looks like inside of Creo. So here we can see this is our Creo user interface, and we have this plastic part that we need to make a mold for. And this is from our Polaris snowmobile data set. And the tool, the mold and dyeing cavity, core cavity, those have already been created. So this was done using our tool design extension inside Creo, where we can take that part and create the mold and appropriate mold around it. But let's take it a step further now and say, okay, great, I've designed my part, I've designed my mold so that it's going to come out as a high quality part. But let me now make sure that this comes out as a high quality mold. Let me put that NC programming toolpath right on it from inside Creo. Let me take it, all the way from the design, all the way through the manufacturing process. So you can see here that we have our cavity, and we bring that in our manufacturing file. So we're now, your Creo knows now that we want to manufacture this, that we're manufacturing a mold. So we can look first at our tools. This is our tool setup library, and we can see that a lot of our common tools are here. And those all have the parameters and geometry that you can change and customize, of course. And we see in our mill tab that we have special tools for all of our different types of milling, where that intelligence is built in. So it helps you create really effective toolpaths for each of these different types, because it has, it knows what you're trying to do. So first we're going to do a look at our mill window. And we're going to add a toolpath by selecting a tool. So our mill window is the volume of space that we want our tool to work through. And then we choose the tool, which is that face mill that we have selected. And so this is the automated toolpath that it created for us based on defaults and the intelligence built into Creo for effective toolpath creation. But now we can make changes if we want to. So we see we have our reference surface, and we can change the value. We also have this list of parameters where, okay, we can change the step depth, the tolerances, the cut feed, whatever it is that you need to tweak from that automated toolpath, you're able to do that. We can also change, here we can see we want to change those ends that we're circling around for. And these are just the commonly used parameters. There are a ton of parameters that you can change. You can get as detailed as you need to get into this. And now we're going to look at how we play that path. So this is that toolpath simulation that we're going to see. And we can see with each path we're following along. We can see the lines. We can see all that CL data up there. And then we can look at it in a solid preview mode as well. So if we're not quite sure how that toolpath is this correct? Is this the right toolpath? Could I make a better one? Well, let's double check with the stock model. So let's get even more detailed and see what is it going to look like when that material is actually being removed step by step. So you can see that facing operation brings us right down to the top of our piece. So once we have a toolpath that we like, we can move on to the next one, or we can save this as a template. So like I said, saving as a template, as an XML template, first of all, it's very easy. It's a simple menu. But this is going to save the strategy, not the geometry. So this can be reused on any future part. When you have that strategy, it's that lace option, it's the step depth, it's the tool that you're using. Those can be applied now to accommodate tools in your future, so you don't have to change those parameters every time. We're going to look now at our high-speed milling options. We can see we have all of these 4 processes with their own separate tab. And again, we're just going to choose the tool, choose the volume that it's going to work in, choose that mill window, which we have here is inside our cavity, and then we can change the parameters. So we're allowing Creo to do most of this work for us. And then if we need to get more detailed, of course we can. We're looking at constant load now on the tool. We can look at our rough options. We have options for the coolant here. You can always add more parameters to your menu. And you can always get more detailed if needed. So now we're going to move on to our rest rough. And again, we choose the tool that we'd like to use. We choose the volume. And this is really all there is to it. We just say, make a few edits, and we're ready to move on. So this allows us to spend time on the things that really matter. We're not wasting time, drawing all these toolpaths out as needed. We're not wasting time recreating any data. There's a lot of tedious work involved usually in NC programming, and this automated toolpath generation and the common data model, these really save a ton of time. So the rest finish here. I should also mention that because these are special, we know that these are our finish, our rest finish. It knows what you're trying to do to remove that material, closer and closer to the walls. So you'll see that it does the calculation. It figures out where your material is left over from the process before, and then it takes the tool into the appropriate areas. So this really is a very effective, efficient toolpath that it's making for you based on those different processes. If we want to say, bring up our whole template, so we can either do that by the standard template, or the standard whole creation that comes with Creo. We can do that. If we'd made some changes to that standard whole creation, how we do that, and we saved it as a template, all we have to do is pull it up, and you'll see it knows the strategy, it knows the tool, it finds the geometry, those lock holes. We have those in all of our parts, for example, all those molds. So it knows what it's looking for, and it can do that for us. So now we can look at our solid preview. Let's make sure everything looks good. We can start by looking at our roughing processes. So bringing it up to our material removal simulation, turn on the target so we can see, how is our part coming out of this? How close are we to removing all this material? You see we have gouge check on. So if there's any problems with gouging or hitting, our collision check is on. So if we're going to collide with anything, we'll know that from this simulation. So we can see there's still some material left over there. So let's look at how our finishing processes remove that based on those toolpaths that Creo made for us and those parameters that we changed. You can open up a stock model. So we have obviously here the rough in process. So this is what it's going to look like after our roughing has completed and we're ready to start the finishing. So this is where we're going to start with our model. Again, turn on one of these options, however we want to see our simulation play out. We can turn our toolpath off, and we see those edges now coming out of this much more precisely, much closer to our final product. So this was all I had to show today. if we're going to come back for a summary, talk about what our customers who have adopted this process have found the most value in, and that's reducing the time to market. This process eliminates a lot of rework, a lot of time spent recreating data. It also takes out a lot of the tedious work that's often associated with the NC programming by having that intelligence built in for us. We're also able to reduce the product development costs for a lot of our customers with this tool. There's less error, there's higher efficiency. This all works for a better efficient development, as well as increased product quality and accuracy. When you have control over the whole thing and you have more time to focus on the areas that need extra attention, you're really going to be able to increase the quality and accuracy that you're able to create with this mold. And all of this works to increase your customer satisfaction, because lower manufacturing costs for you and better lead times, that all means that the customer is getting the product they need faster, potentially for a lower cost and a higher quality, of course, which customers always appreciate. So that was all I had to show for mold machining today. I can pass it back over.
Thank you, Emily, for presenting. I'm not seeing any questions in the queue, but I do want everyone to know that we are running a promotion until the end of March. You can get 50% off of these specific Creo extensions with the purchase of a new Creo license. The link to this promotion will be in the email I send this afternoon, along with a replay. And just a reminder that survey